So how did you do? Did you manage to figure it out? What is 9 to the power of that will give us the answer of 3? I'm sure a lot of you started by trying out negative exponents, and that's certainly what you would think you would do. I wonder if any of you put a fraction in that exponent place. You see, the square root sign actually has an imaginary 2 over there, and we all know that 9 has an exponent of 1, which means that that can actually be written as 9 to the power of a half. Now, why don't you try it quickly on your calculator? See what you get. 9 to the power of half is equals to, did you get it? You should have got 3. So that means when I have a rational exponent, and by that I'm really talking mostly about the fractions, the top, the numerator, is the exponent of the base, and the root is going to be the n, or yes, the denominator. Now I've made a huge mess of this slide, so why don't we go on to the next question, and now we're going to just do some maths and get into the swing of things. Please remember that you have done all of these skills before, so you can do this. It's just a bit of applying little bits from here and little bits up there and bringing them all together in a beautiful woven basket. That's what maths is about. Now, while we are busy doing other questions, why don't you take down this challenging question? Write it down somewhere, and when you get a little bit bored, or maybe you go ahead of time, try and solve it. See if you can figure out what the answer is going to be. And we'll check at the end of the day. Okay, the first question. Now, this type of question is simplifying a simple exponential expression. And remember, we said an expression was something that you could not solve for. You could only simplify it. The reason why this is simple is because there is only one term in the numerator, and let's write that down, and one term in the denominator. And this is very, very important that you pay attention to. So when you have one term in the numerator, it means that there are no pluses or minuses between the bases. So you can cancel, and it makes things so much easier. As soon as you see a plus or minus in the base, then you know you're going to need to factorize. So that's what takes it to the next level. As soon as you've got more than one term, you're going to have to factorize, and it gets a little bit more complicated. But this one we don't have to. Now, as I've said before, maths is all about making it easier for yourself. So one of the first things I want you to do is to circle the things that make you feel bad. So let's take a look at it. And I'm just going to guess what I think will make you feel bad. You see, the 2 is good, but this 4 to the power of x doesn't fit in. This 2 is good, but this 16 to the power of x doesn't fit in. So I'm going to leave the things that make me feel good, and I'm just going to work with those that make me go, ugh. So 2 to the power of 2x, it was there before, it's going to stay there. I'm going to change 4 to 2 to the power of 2. Can you remember what that's called? If you said prime factorization, you are correct. Okay, then 16 is actually 2 to the power of 4. And that's raised to the power of x. Okay, so now I've made things look a little bit more happy for myself and made me feel a little better. The next thing I need to do is to apply whatever laws of exponents I can. One of the things that may be making me feel a little uneasy at this moment are the brackets. So that's the next thing I'm going to get rid of. I'm going to leave everything else as it is for now because it's working for me. And maths is all about making it easier. So let's get rid of those brackets. Now remember, we're raising to a power. So I'm just going to write down 2 to the power of 2x because that's already there. And because we're raising the power, we multiply the x on the outside with the 2 on the inside, and that's the exponent 2. And then we multiply by that leftover 2. And at the bottom, we have 2 to the power of 4x. Okay, ladies and gentlemen, this is starting to look a little bit more like a grade 8 problem, so now we can move on. And we've got 3 bases at the top that are the same, so we can add their exponents, giving us 2 to the power of what is 2x plus 2x. If you said 4x, I'm proud of you. Now, what is the exponent of this? Remember that if there is no exponent, it's automatically an exponent of 1. So we have 2 to the power of 4x plus 1 on the top, and we have 2 to the power of 4x on the bottom. Now, many of you are going to sit there and go, but that's not how I would have done it. I would have taken all of the exponents to one level, and then I would have added and subtracted them all together, or maybe you would have written things out in expanded notation and then cancelled off, or you would have done it my way. Every single way is correct. That's the strange thing about exponents, is that you can actually go at them at all different ways. Okay, so now I'm written out my problem in a particular way because I want to explain something that a common misconception that I often see, and I don't want you to get confused with it. I like to call this misconception Christmas decorations. Why? Because Christmas decorations make us feel good, and maths is all about making us feel good. So, if I was sitting in my grade 10 exam and I saw this problem, I would cancel off 2 to the power of 4x and 2 to the power of 4x. But then, can you see my problem? I don't know what to do with that plus 1, because I've cancelled this and I've cancelled that, and now I have a nice little Christmas decoration hanging off my Christmas tree. There it is. So what do I do with it? We must always remember that this started off, and let's just rewrite it over here, as 2 to the power of 4x times by 2 to the power of 1 over 2 to the power of 4x. Now, if I divide it up like that, it's a lot easier to just cancel off that and get our final answer of 2. Okay, grade 10s, we're now going to leave you for a little while to try one of these problems on your own. Remember that you need to prime factorize everything and multiply out the brackets before you start collecting exponents and stuff like that. So let's take a look at it, and you can have 5 minutes to do it. So how do you think you did? Shall we check it out and go through it together? I hope you all prime factorize the bases first and then multiply it in the exponents and all sorts of things like that. There are a couple of tricks there, so we'll go through it step by step. Now, the first thing I'm going to do is circle the things that make me feel unhappy. I've got a 20 and I've got a 16. So the 20 is 2 to the power of 2 times by 5. And that's when it's been prime factorized. It's still to the exponent of x plus 1. Then 4, actually 4 bothers me a little bit as well, because 4 isn't prime factorized. It should be 2 to the power of 2 to the power of x. And at the bottom, 16 is 2 to the power of 4. And we have x minus 1 times by, and 5 obviously is a prime factor, so there we go. Now, the next step is often where people will make their first mistake, and that is multiplying out those brackets, or in other words, raising the power. Remember that 5 has an exponent of 1, and that x is going to multiply by the 2, but the 1 is also going to be multiplied by the 2. And same with the x and the 1 and the 1 and the 1. So let's see what it looks like. 2 to the power of 2, x plus 2. And there we go. It was the x times the 2, and the 1 times the 2 gave us x plus 2, times by 5 to the power of, what's x times 1? It's going to be x, plus, and what's 1 times 1? 1. There we go. Then I'm going to carry on putting my big time sign between, just so that I can figure out what's going on. Otherwise it gets a bit messy. I've got 2 to the power of, what's 2 times by x? I hope you all wrote down 2x. Okay, now at the bottom, it's going to be 2 to the power of 4x minus 4. Not minus 1, minus 4. And the reason why it's minus 4 is because that 4 multiplies by the x and by the negative 1. It's almost as if the exponent has a bracket around it. Same with the top one. Okay, now going back, we've got times 5. Oh, I want my green. Times by 5 to the power of x. And now it looks a little bit higgledy-piggledy. Okay, so grade 10s, now we have prime factorized the bases and we've collected, we have raised the power of, and we've got everything together. Now I'm going to collect all of the bases that are the same and put the exponents in their places. Now remember, the only reason we can do this now is because we only have one term in the numerator and one in the denominator. And that means we don't have to factorize or anything like that. We can just straightforward apply the laws of exponents. Okay, so I'm going to start with 2. I've got, and let's put this in, there we go, 2 to the power of 2x plus 2. And then I've also got 2 to the power of 2x. So I'm going to add that 2x, and then I will multiply by 5 to the power of x plus 1. And that's all over, and let's move down a little bit. That's all over 2 to the power of 4x minus 4 and 5 to the power of x. I'm going to simplify the top because it's a little bit ugly. So I've got, what is 2x plus 2x? It's 4x plus 2. And times by 5 to the power of x plus 1, all over 2 to the power of 4x minus 4, let's put the x in, and minus 4, times by 5 to the power of x. Okay, now I'm going to bring all of the exponents up to the same level because it just makes me feel better, and maths is all about making you feel good. So it's 2 to the power of 4x plus 2, and because we're dividing by 2, we're going to minus 4x minus 4. And then we'll throw in our 5, and we've got 5 to the power of x plus 1 minus x, and I would put brackets in, but I'm running out of space, so I won't. And now let's collect like terms. Now, if I were to multiply this out properly, which I probably should, but I'm going to just save time and just write it over here, I would get 4x plus 2 minus 4x plus 4. So that would give me an answer of 2 to the power of, and let's go back to green, 2 to the power of, what is 4x minus 4? Well, that's nothing. And 2 plus 4 is going to be 2 to the power of 6. Okay, so the next one. I've got 5 to the power of x plus 1 minus x, so that gives me 5 to the power of 1, which if we type into our calculator will give us an answer of 320. So, did you get it right? I hope so. The next question we're going to look at is one that requires factorizing. So now we'll be able to see what it looks like when it's got more than one term. But we're just going to go to an ad break first. Thank you.